Okay, everybody, so now that we understand the process on how to rationalize the denominator, we have to discuss what happens if the denominator is not one term a monomial, but instead two terms a binomial. So if you look at your PowerPoint at your expression, you have 5 divided by 1 plus square root of 2. And you will see in that expression 3 operations. There is division, addition, and square rooting. First question. Can you add the 1 to the square root of 2? And we know the answer is no because they're not alike. 1 is a whole number, square root of 2 is not. Then I would ask, can you square root 2? And you would say, no, it's in simplest form. 2 is prime, it's as low as it can be. Then I would ask, can you divide 5 by 1 plus square root of 2? And again, the answer to that is no because you cannot divide a monomial by a binomial. Okay? And you can't separate that. You can't say it's 5 divided by 1 because it's not. It's 5 divided by 1 plus square root of 2. So you can't do any of the operations in that expression. Isn't that great? So now the question is, I just leave the answer like that? And again, that answer is no. Because if you have a division bar, a fraction, the denominator of a fraction must be a positive whole number. 1 plus square root of 2 is not a whole number. So you cannot leave that in the denominator. So that's where the process of rationalizing comes in. It's a fancy word that says, make me an equivalent fraction. And from 3rd grade math, to make equivalent fractions, we do the operation of multiplication. So the question is, what am I going to multiply to 1 plus square root of 2 that's going to guarantee it turns out to be a whole number? Now, the difference in this module is 1 plus square root of 2 is a binomial. It's 2 terms. So to rationalize it, you have to also multiply by 2 terms. And the way it's going to become a whole number to get rid of the square root symbol is the rule is you're going to multiply by its conjugate. Now, we've heard that word a long time ago, way back in the beginning modules. The definition of conjugate never changes. Conjugate means you make the middle symbol the opposite in the binomial. So, what is the conjugate of 1 plus square root of 2? Very good. It's 1 minus square root of 2. So what we're about to do is rationalize. We're about to multiply both the numerator and the denominator by the conjugate, 1 minus square root of 2. And what that's going to guarantee us is the denominator is going to turn into a positive whole number. All right, let's try it. Let's look at the example in the PowerPoint. 5 over 1 plus square root of 2. So I'm going to multiply by the conjugate, 1 minus square root of 2, 1 minus square root of 2. When I multiply the numerator, because remember, multiplying fractions is no problem. Top times top, bottom times bottom. When I go to multiply 5 to 1 minus square root of 2, I have to use my distributive property. So 5 times 1 would be 5, and 5 times negative square root of 2 would be negative 5 square root of 2. The 5 stays on the outside, the 2 stays on the inside. Okay? Now when I do the denominator multiply by conjugates, Miss Black is not going to do all of first, outer, inner, last, because we've already discussed this. There's a shortcut to multiplying conjugates. All you have to multiply is the first term with the first term and the last term with the last term. So if I multiply the first 1 times the first 1, I'll get 1. If I multiply the last positive square root of 2 times the last negative square root of 2, well, a positive times a negative would be negative. Square root of 2 times square root of 2 would be square root of 4. Now I know what you're thinking. You're saying, Miss Black, there's still a square root in the denominator. But look closely what number is inside that square root. There's a 4. What do you know about the square root of 4? Oh, I can do that operation now. It's a perfect square. So now in my numerator, nothing changes. I leave 5 minus 5 square roots of 2. But in my denominator, I have 1 minus 2. Because the square root of 4 is 2. And I know in the denominator, 1 minus 2 would be negative 1. So if you look, by rationalizing, I got the root symbol out of the denominator. So now my fraction is, in the numerator, 5 minus 5 square roots of 2 divided by negative 1. Now, we still have a problem. We've talked about this. You can never, ever, ever leave a negative sign in the denominator. Where does it float to, ladies and gentlemen? That's right, it floats up to the top. The problem in your numerator is you don't have one term, you have two terms. So you're going to float that negative to both terms. So the 5, when the negative floats up, will become negative 5. The negative 5 square roots of 2, when that negative floats up, will become positive 5 square roots of 2. Because if you follow your rules, a negative divided by a negative would change to a positive. Do we have to write a denominator of 1 with a fraction? Think back to 3rd grade. Do we write 5 divided by 1? No, 5 divided by 1 is 5. So we're not going to leave the denominator 1. Now that it's a positive and a whole, we just don't need to write it. So that's why the solution here is negative 5 plus 5 square roots of 2. And that's an acceptable answer now because now it's no longer even a fraction. Okay, we're going to practice rationalizing. Let's go to the whiteboard.